Guys, we're on page 35. And let's go take a peek at this guy up here. This is something new. And sorry, this right here goes with this over here. So we're going to skip that for right now. I just want to focus on this graph. And this is, again, some calculus-y terminology. Anyone remember what that arrow means? Approaches. So as x approaches infinity, you guys agree, I gave you the x-axis is right here. Boom. There's the x-axis. It says as x goes to infinity, do you think we should go infinitely to the right or infinitely to the left? Yeah, as x is going to infinity. So that's saying as we go as far right as we can on my graph, what are my y values doing? They're approaching infinity too. So we'd say my y approaches infinity. What about over here? As my x approaches negative infinity, and maybe you want these little arrows. That just means as we go left on the graph. Above it just meant when we go right on the graph. If I look all the way left on the graph, as x goes all the way left, what are those y's doing? Negative infinity as well. Y approaches negative infinity. You guys, this little guy here, I'm going to even save us some time. End behavior, these infinities are all dictated by that biggest exponent. This is an x cubed. What does x cubed look like with our arms? Boom. What's a negative x cubed? Boom. That's all I care about. So it's going to be like this. Boop. I don't care about how accurate that is because I only care about what's going on at the end. So I'll even show you. Negative x cubed plus an x squared and then minus an x plus a 5. Boom. It's got the general shape of that negative x cubed. We don't care what's going on in the middle, how high, low, left, right. Doesn't matter because they just are curious what's happening when x goes to infinity. Again, that's just saying as x goes all the way to the right. As x goes all the way to the right, what are my y's doing? They're going to negative infinity this time. So we'd say my y approaches negative infinity. And as x approaches negative infinity, as x goes all the way to the left, what's my y doing? I heard it. Positive infinity. You can write positive infinity or you could just write infinity. The positive is not needed, but it wouldn't be wrong. Okay, we're going to just do these 3 problems real fast. Let's think about this guy. What's my parent function here? X squared. Where am I going? I'm taking it right 5, then up 3, and then I'm flipping it over. So let's go right 5, up 3, put that little vertex there. Then it's facing down. So I'm going to say, all right, 1 squared is 1, but I got to go in the negative direction. So I'm going to say down 1. Negative 1 squared is 1, but I got to go in the down direction. 2 squared is 4. 2 squared is 4. 3 squared is 9. 5, 6, 7, 8, 9. And 9, all in the negative direction. If we look at this graph, look what they're wanting. They want to know when is this graph increasing. Would you say my graph is increasing or decreasing here in pink? Increasing or decreasing? It's increasing because those y values are getting bigger. What's going on here in blue then? What are those y values doing? Now they're decreasing. Okay. This is where it's going to mess with our mind, but I want you to take some notes here. The increasing and decreasing is all about the y values. That's all about the y values. And then when they say determine the interval when it's increasing, this stuff needs to be all x values. The answers are all x's because it's saying from this x to this x, my y's are increasing. Okay, so this is when some people are not going to be happy about this. Let's try it. You agree, my function is increasing in pink. Those y values are getting bigger. My question is, from what x to what x do my y's get bigger? Say it, Jacoby. Negative infinity to 5. Look at what he just said. Negative infinity to 5. Let's talk about what the heck he's talking about. Do you agree this graph is going on forever to the left? To the left on that x-axis is negative infinity. So as far left, and we go, so because I don't want to graph that much, these y values are always going to go down. So my y values are increasing for every x value up until that maximum of 5. We feeling okay with that? Okay. Will I ever put a bracket on an infinity? Never. I'm not going to put a bracket on 5 either, even though 5 is closed. But you agree at 5 is not necessarily increasing or decreasing. It's the highest point. Then what does my function start doing? Decreasing from what x to what x? Close. 5 to what x? I agree my y's are going to negative infinity. What are my x's doing? All the way to positive infinity. And that is such a common mistake. He's saying from 5 to infinity. Henry, but I agree. Like, it's so tempting to say to negative infinity because I agree that's where the y values are going. But that's why we're saying it's decreasing here, because I agree those y's are going to negative infinity from the x of 5 all the way to the right, which would be positive infinity. Cool. You guys, a critical point is just the max or min. At what x value do we have that max or min? We would just say at 5. What's this graph looking like? What's that shape? Whoosh. 3 to the left, 5 down, skinnier or wider? Wider. Okay. 3 to the left, 5 down, wider, up 1 over 2. Boop. Boop. Would. What's my function doing in blue here? Increasing or decreasing? Decreasing. Then what's it doing in green? Increasing. Those y values are increasing from what x to what x? Again, these, oh gosh, that's a terrible little thing. Whoop, whoop, have to be x values. From what x to what x are my y's getting bigger? -3 to infinity. Very good, Henry. He's saying, all right, green starts at -3 and all the way to my x is infinity. Hen, do you agree? My y's in this case, my y's in this case also happen to go to infinity. Doesn't matter. You know what I'm saying? This infinity has to do with that x-axis. So good. Let's talk about blue. For what x values are those blue going down? For what x to what x? Boom! She just dropped that karaoke mic. -infinity to -3. Real fast, anytime we write these intervals, you gotta put this in order from least to greatest. I don't want you putting -3 to -infinity. That makes me gag, okay? We got to go smallest number to biggest number anytime we're talking about an interval, okay? Okay. Critical point would be when x is awesome. That's just a term that actually my AP kids will learn after Thanksgiving, that critical point. Okay, this last one. Do you agree? We know the general shape of an x cubed, but I don't know what this stuff is going to do. I want us to practice with our calculator. So if you could grab your Calci, we want to go graph this function, which is x cubed minus a 2x squared minus a 5x plus a 6. Okay, you guys, looking at this graph, what would you say before? Don't graph it yet. Don't graph it yet. Don't graph it yet. I want to talk and then we're going to graph. What's my function doing here? Increasing. Then what's my function doing here? Decreasing. Then my function is doing what? Okay, so we got 2 times that's increasing, 1 time that's decreasing, right? What do I need to find here to help me figure out where it stops increasing and starts decreasing? That's a maximum, you guys. What's this thing? A minimum. So here's what I wanted us to practice together. I'm going to get rid of that thing. We're going to go to our calculator, and I want to remind everyone how to do this. We're going to hit second trace. I know you've done this before, but let's go find that maximum first, option 4. It says, what's the left bound? You got to hit those left arrows till you're on the left side of that maximum. So I just moved my cursor just till I'm on the left side of it. There's no perfect answer. Then I'm going to move my cursor right till I'm on the right side of it. And then I got to hit enter one more time for my guess. I'm not guessing. Calculator paid $100 for you. You can find it out. You know what I'm saying? Guys, what is that maximum point? Did anyone get? Yeah, -0.8. And then 8.3, 4, 5, 6, 7, 8. Okay, so I'm going to go like this. I'm going to say that's -0.8, 8.2. Are we going to be perfect on a graph? No, and it's fine. It's fine. But we have that point. Writing that point on your graph will be crucial in helping us with the next step. So writing, not only drawing the point, but writing its coordinate, -0.8 and 8.2. We're going to need that later. How are we going to find that minimum? Second trace 3 is minimum. Then I have an add. I'm going to go left bound, enter. Right bound, enter. So it's telling it where that minimum will be. And I got a 2.1, -4. And again, where you have it on your graph is not as important as writing the actual values. So when I go draw my function, I'm just gonna be like, okay, there's a max there and there's a min there, and then I'm just gonna draw the rest of it. Don't really care too much about my accuracy other than we have a max there and a min there. We already said this once. What's my function doing in purple here? Increasing. Let's talk about from what x to what x, where my y value is getting bigger. From what x? We're on the left side of the graph, so we're going to be talking negative infinity to what x? Love it. Agreed. Then my function does this. And does what in green? Decreases. My y value went from 8.2 to -4. That's a decrease. From what x to what x? Love it. -0.8 to 2.1. And then it's getting a little sassy on us. What does it do again? Increases again. From what x to what x? Good. It doesn't have to do with my y going to infinity. It has us doing it all the way to the right of the graph, right? So we got to say, and it's also increasing from 2.1 to infinity. Look at my cute little union sign. We had 2 times that we were increasing. My critical points are at what x values? Where are my maxes and mins? Love it. -0.8 and 2.1. Love it. So our homework's going to be pages 37 and 38. I'm going to throw a key up so that you guys can check your work.